Okay, so let's get started. We'll do some settings first. So in case you don't have Thonny, you just start by typing CMD for command prompt and run this. And you just type pip list. So there will be a list of modules under Python. Okay, so let's see if Thonny is already installed. Okay, it's not. It starts with a th. So let's install it. We'll do pip install Thonny and just hit enter, let it do its thing. It'll take a short moment to download all of these modules and then install them. But if you do type if you type pip list and the Thonny is already in there, then you don't need to reinstall. Everything should already be installed. But I can be sure with all these lab computers, they do wipe the drives at times. So may need to reinstall this. Just type um, pip install Thonny. So Thonny. So we're just going to pause here, and we'll be back to continue um, after the installation completes. So now that the installation has been completed, I can run Thonny by typing this python-m Thonny. I already have Thonny installed as an independent program, but this should install it under Python, so it still runs. There are two different programs, so there we go. And it's already running because it's already been configured. Otherwise, it'll give you a dialog to ask you to okay that to enter into a certain interesting, simple window that looks like this. I have it with dark theme. You start with a bright theme. So if you have something that looks like this, maybe nothing over here, all you have to do is just go view files, a list of files. So these are your local files. These are the files on the board, the MicroPython board. So if it doesn't show like this, it'll probably show up like this, running your local Python. It'll just run like this. So you go to the bottom right corner, click here, and choose the MicroPython RP 2040. And under USB serial device, just click this one. It'll connect. So if this is bothering you, you can always minimize that. Okay. So now it's actually running Thonny on the board. And we can start. Um, let's see where the program is. I already typed it up. Mm, incline here. So okay, I guess I need to update my repo. I think I did that at home. I just need to fetch the update. This doesn't really concern everyone because you will be typing the code. Okay. Well, I thought I had the code already in here. Mm. Oh, here. Okay. Here we go. So I just open Thonny. This is my version. It's a long version with a lot of comments. And I'll just need the lines that are necessary for our very basic uh, lab setup. So I started a new file. I just pasted everything here. And again, for you, you have to type everything up. So what do we need? We need this. Mm, we'll need only the ones that are in here. Um, we don't even need a try, but let's do this. We will not print out the tilt angle. So let's have a look at the printout. We're printing out the AX component, Y component, Z component, and there's also a tilt. That's because I calculated the tilt. So I'll cut it out. Pretend that I did not. Put it in comments. Oh, There, okay. So just kind of put it in comments here. And this should be ready to run. So let's go ahead and run it with the run button. Okay, it's already printing. And as we can see, AZ is almost 1G. So that means the board is almost horizontal. But AX is indeed a little bit close to zero point zero 0.02. We can certainly make it slightly better. See, AY is close to 0.01 maybe. So I'll just use my hand to tilt the board. Let me get the video. This may not be easy to see. So I'm right here, and let me get the printout. So the printout's here, and you can watch the printout and see how this uh, improves the AX if I tilt this side up with my fingers. Looks like the number is getting bigger on AX. So this end is okay. The other end needs to be tilted up a little bit. Yeah, this end could tilt up a little bit, but not much, just a little bit. So I'll just take some putty and I just make two tiny little balls, and I'll put one on each of the rubber feet. Just kind of lay it flat and read the numbers again. Okay, the numbers are getting better. So I'll just tap down a little bit so that the balls are sticking to the paper right here. Okay, I think I'm getting slightly better. 0.008, 0.012 instead of the consistent 0.02 something, right? So it's a little better, and the Y didn't really change by too much. Okay. So this is a good starting point. Even if you don't correct for this, it would be fine. Okay, so let's see. I still have the share screen going. Okay, so I'll minimize my video. And next I'm going to um, copy, for example, 5 files. So how do I do that? Well, I'll just stop this from running. Let's see. I can stop, restart, but I probably should just click here and Control C to force it to stop. See that this is nice. It captures Control C. It doesn't just break out and say, ah, something bad happened. I have to break the code. This is handled well with the little try loop. You don't really need that, but it's a nice thing to have. So just select 5 rows of this, and you can copy paste this into your Excel spreadsheet. For instance, we'll do we'll have a new Excel spreadsheet running in a moment. Sorry, my computer's a bit slow. Okay, here, Control C, Control V would be pasting them. Okay, well, there are all these AX and AY and the AZs and Gs. Probably we can change the formatting so we don't have to start deleting these in Excel. That's not necessary. All you have to do is to change the formatting and not print out AX equals anymore, not printing the G anymore, but at least inspect your readings and see if they make sense before you start deleting out all those nice human readable strings. Okay, so that is one angle, and now I'm going to and 5 degrees. Like I said, when I'm calibrating the inclined plane, the indicator of the angle, the bottom of that lines up with the bottom of each division on the protractor. So I'll do that. I'll go to 5 degrees and using the bottom of this indicator to line up with the 5 degrees. So I'll just loosen this up, go to 5 degrees, and really lower my head so I can see at the right level. Okay, this is not really very secure. So make sure you secure the screw extra hard so it doesn't come right down and just slam on the base of the inclined plane. Okay. All right. So now we have 5 degrees. I can restart this program just by clicking the run again. So it runs again. As you can see, there's already some indication the AX has gotten a larger angle. So all we have to do is to make sure we're our cursor is still here, Control C to interrupt, and we can copy 5 rows of data for averaging. You don't have to do this 5 separate times, stopping in 5 separate times. You just stop it one time. This should be good enough. And we copy that, and then we can go to Excel. We can paste it. Like I said before, once you're sure the data are good, you want to change the formatting, so you don't copy paste all this AX equals and the G and such. So you can just copy paste the values if you just print out the values. Okay, so this will keep going until we have 45 degrees. So let's go straight to 45 degrees to save some time. For the rest of you, you will have to go 5 degrees at a time. And because I use the putty to hold the cable here, this makes it extra easy so the cable does not try to move the board. And the board also has a couple of little putty blobs on two of the feet, so that's nice. They also keep things from sliding, and that will be an absolute must if you go to such a high angle. Make sure you secure your inclined plane just by tapping it down. Make sure it doesn't all of a sudden collapse down. All right, it's good. So now we can go back to Thonny and restart the code. Okay, this is quite a bit larger. See that? The two coordinates are almost exactly the same. This is the indication of the 45 degrees because we're going for tangent, opposite or adjacent. So if opposite and adjacent are the same exact lengths, that is a 45-degree angle. So we're pretty good. This is what we expect. So we can Control C, stop it, and grab 5 sets of data. Again, do not print out all the human readable strings. So your copy paste will be clean with only data. Okay, so now we have this. We should be able to calculate the angles and then average angles every 5 trials. All right. So here's a challenge for you. I have this originally printing out the angles. So I want you to add that into the code. The code isn't difficult. You just have to import the arctangent. And maybe you want to read what arctangent 2 is. It's easy if you just Google it. Um, so once you have the arctangent 2, you should be able to calculate the angle, display the angle, maybe not the components anymore because now you have your bubble level made of the black circuit board. You can hold it to see if the angle is correct. The nice thing about this arctangent 2 is it is actually able to cover the full 360. So why is that so compared to arctangent, which is only plus minus 90? Well, you can answer that question yourself once you read about arctangent 2. How to call that function is very similar to arctangent. And also make sure you're printing out the angles in degrees, right? The angles are automatically returned in readings. We did that already in class, so it won't be a surprise. So that should be it for data collection. I'll have another video for the analysis.